The only metadata you need, I think, is this is an executable program. This is not an executable program. And maybe this is a symbolic link. So in terms of the things I've posted to the Tech Live list, the only Git technology I believe I'm using is the Git pack file, the way in which Git pack files are organized, and the way in which they're indexed. And the index is something that's computed from the pack anyway. The most complicated thing in the Git pack file, I think, is that it uses zlib compression. As I vaguely recall, you can set up a pack file not to use zlib compression, but it's probably what we want to use. And zlib is also something widely used because it's used inside PDF for compression. So again, it's a sort of well-supported standard. And if all we're using is Git pack files and their associated index files, there's very little to go wrong, and there's very little required to port it to another platform. Now, that's a question of distributing everything, distributing all the tree information. Oh, I'm also assuming the data structures, the tree data structures that Git uses. So Git has a data structure for a tree, and it consists of a series of entries, and with each entry, you have a secure hash. That's what a tree is. And each secure hash in turn resolves to something. If somehow you can manage to break the secure hash algorithm, then you could produce a tree that has infinite descent, but we can't break the algorithm, can we? So we won't get those trees existing, I hope. So those are the only sorts of problems you've got there, and those are problems inherent in using content addressable stores. The alternative is to say everything is safe because nobody has got in, not even the cosmic rays, to flip a bit. And I think relying on the cosmic rays avoiding all our computers is foolish. We at least want something to check. I think we probably want both. Now, if there's a platform that doesn't support software development, the interface would be specify what you want outside and build the tree outside and then transfer it to the platform using whatever mechanisms exist. And I think that's fine. So that would allow things to run on VMS even if you don't have a compiler and even if you don't have the ability to run Git on there. I think more serious is the question of how do we make it work with Tech Live executables? And if the executables are historic, then we have to construct a tree in some sense. And on Unix, we can mount all sorts of things, including the SquashFS as a tree. And Unix is a good platform for being able to mount other things as a tree. And it has something called a union file system that's very good in virtual machines that it can use as a tree. So in Unix, we can do these things and pretend that we've got the right tree so that we don't have to change the executables. But for platforms such as Windows, you can't mount the SquashFS. You might be able to mount it under the Linux subsystem, but that's still got the same problems, but to a lesser degree. So if you're going to do everything using Git packs, you'll have to change the way in which Tech Live executables get their files. That instead of the kpathc library saying, here's the file name, you go ahead and open it, the library should say to Tech, here's the file already opened and you can do the operations on it. But it's not necessarily a file, it's just something that has the same interface as a file. So you don't actually give it a file handle. You say, here's an object that you can read and you can seek to, if you need to seek to. But whether it's a file or not, we don't know, and you don't need to know. So if you compiled against a different sort of library where instead of opening files, you see with Linux, you can open a file and it's passed over to the operating system. And the operating system says, oh, this is a special file. We'll get it from the Git pack store and not from the disk.